video 3, I'm going to try to go faster. This time, we still have ax squared plus bx plus c equals y, but things are a bit different because, oh man, when I look at this, there's no prime. 25 is not prime. I've got 1 times 25, or I've got 5 times 5. Also, 9 is not prime. So I'm going to have to try a couple of extra things. I do know that I'm going to need 2 negatives, and the reason I know that is because, again, think about where these values are coming from. If I have a positive here, then I know that the 2 things in here have to be the same because that c value came from multiplying this times this. Well, if I have a negative times a negative, that could explain away my positive. Or if I have a positive times a positive, that could also explain away that positive. But because I have a minus sign here, I know it's got to be negative on both of these. So at least I know something here. Now I've got to think about what my options are. Again, closest things are luckiest. So if you think about your factors of 25, you've got 1 in 25, or you've got 5 times 5. Closer factors are always luckier, so I'm going to try that first. I've also got to think about my factors of 9 because I've got to think about where that c came from. My factors of 9 are 1 and 9 or 3 and 3. So I'm going to try this. I'm going to try using the 5s and the 3s because I want the things that are closer together. Remember, the things you put in front are going to form your A term. So your factors of 25 need to go in those first spots in your binomial. The things that go at the back are going to form your C term. Your constants multiply together to give you that C. So when I multiply this out, 5x times 5x gets me the 25x squared that I wanted. 5x times negative 3 is negative 15x. Negative 3 times 5x is that other negative 15x. And negative 3 times negative 3 is positive 9. Well, 25x squared minus that 30x plus 9. I'm done. We got it on the first try. We don't have to work anymore. You should note that sometimes when you have 2 binomials that are identical, like this 5x minus 3 times 5x minus 3, you will probably see it written like this, where we've just got 5x minus 3 squared. That's going to be important for you guys to know when we get into future lessons, because that's going to help us solve these more easily in a variety of different ways. But for now, solving it, 5x minus 3 times 5x minus 3, I'm going to set both of those equal to 0. Oh, I forgot to set this equal to 0. Sorry. I'm going to set both of those equal to 0, so 5x minus 3 equals 0. And over here, 5x minus 3 is equal to 0. I'm going to add 3 to both sides, which gives me 5x equals 3. And then I divide by 5. So I get 3/5 or 6/10 is what that would be as a decimal. I'm not going to take the time to do this one over here because it's the exact same thing. I'm going to add 3 divided by 5 and end up with 3/5 or 0.6. What that means for the quadratic on this is if I were to graph it, it's going to have an x-intercept at just 0.6, which means its vertex is just barely sitting on that x-axis. So it's only going to have one solution, and that's going to happen anytime you have a problem like this where you have the same term multiplied twice. That's going to end up giving you just that one x-intercept where it's sitting on the x-axis. All right, that was quick and easy. We're going to go ahead and move to video 4. You don't have any U-tries. You'll have some after the next video. I'll see you on the other side.